Sound. Can you guys hear me? I think now you can. Hello. I don't know if you can hear me properly, but I think my mic is not being captured right now. Uh, Let me just recheck it. I'm trying to listen to it through my videos, so you might get a audio loop. Yes, it's okay now because now I can hear my voice correctly. Okay, let's wait for people to join, and we can start. I think this is gonna be a very quick video because we are gonna be talking about uh, attributes and points. Wait. Okay, yes, okay, आवाज आ रहा है ठीक है okay. Let's wait for 5 more minutes. Okay, we have 4 people here. Then everyone got bored of Houdini. Okay, we have 6 people now. Hello everyone. Hi. If you have any doubts regarding anything, obviously not something personal, but regarding the industry, studios, the software, or the topic that we have discussed. So if you guys have any issues, please. And just after 2 minutes, we'll start with the content of attributes and points because that would be the topic for today. And yes, Bhageshri, the next class would be about Vex and WOP, where I'll be talking about like how Vex and WOP are different, but they are the same, and how you can work with Vex or with WOPs, or how not to uh, have it scary. basically you feel that it's a code, or it's everything is connected, the datas and everything. So I would make it easier for you to understand that this shouldn't be scary. Okay, and hopefully you'll get to understand and have a gist of how it's working and what's the difference and everything. And later after that, we will also use many of the examples for simulations and warps and vex. But this, as the session goes, it's for beginners, right? So I cannot go much deeper into that, but I will make sure that you understand what's going on and what is what. But after that, you can find a lot of videos on my YouTube channel, or you can also join my Damn Houdini course if you're interested to dive deeper into Vex and Wops and how we can manipulate and use every stuff that is available in Vex and Wop, and then carry from there. Hello, Otaku. Hi. So please make sure that you have subscribed to the channel. Please do subscribe. And we are gonna start soon now. Cool. So we do have 7 people here, and let's start. Okay. So I'm gonna share my screen, and let me be a little smaller. So I'll just be here in the corner. Yep, something like this. Yeah, cool. Somewhere that you can see me. So this is not the Houdini that I should be sharing. Wait, I think I'm not sharing the correct screen. Let me change it. Yep, great. So we are gonna talk about attributes and points. Okay, so before understanding what attributes are, I would like to talk about points. Okay, so let me take a geometry here, and you don't have to focus on the nodes that I'm placing here, just focus on what I'm talking and what exactly is the situation. Okay, so I'm just taking a single point, right? It's at 0 0 0. If you can see, it's in the middle of the grid, like on the center of the grid. This is a grid. Okay, and if you don't know about the grid, basically in Houdini we work in meters. Okay, so every grid that you see is 1 meter, 2 meter, 3, 4, 5, so on and so forth. Okay, so the point that I have taken here is in the center of this grid. It stands at 0 0 0. So what exactly is a point? So point is something that exists in the 3D space. Okay, it can be anywhere in the 3D space, and by 3D space I mean anywhere in either X, Y, or Z, right? So when we talk about 3D, there are three axes, right? X, Y, and Z. When we talk about 2D, it's a flat surface, and we can draw a third axis, but it gives you a perspective of our depth. But we only have a flat surface, right? But in 3D we do have three axes, and for example, this is my X, and this should be my Y, and this will be my Z, and something like that. Okay, so in 3D also, whenever we take a point or something like that, it will exist in a 3D space somewhere. Okay, for now this is existing at 0 0 0, yeah, meaning at the center of the grid. And why points are important in Houdini is that anything that you will do or create or import or make, or any simulation, be it particles, destruction, water, everything is points in Houdini. Okay, so when we talk about polygons or primitives, as you may know that a surface is called either a primitive or a polygon or whatever you call it, but in Houdini, that polygon or that primitive itself is created from points. Okay, so let me show you an example here. If I take a sphere, right, this is a sphere. Cool. So as you can see, this is a 3D model or 3D polygon or 3D surface, right? Because you can see it is a polygon, it has this corners and this depth and everything. But if I show you something, for example, I delete the geometry, this is what we have: points. Okay, just points and nothing else. So everything that you will create or either import or have in Houdini would be having this points, right? With points we do get a attribute. Okay, now I'm going to talk about attributes. Basically, I hope that the point structure, the point definition is clear to you guys, like what exactly is a point. I'm waiting 2 minutes for you guys to ask me anything if you have any doubts. No doubts? Okay. Regarding the render visibility and holdout, I think this won't be the place that I will answer about this, because that's a different topic. Okay, so maybe you can text me on WhatsApp and then we can discuss, Rahul. Okay, so cool. Uh, we will start with attributes. So what exactly? So these are points like okay, this so a primitive or polygon a difference. Okay, so basically any surface or anything that you see in Houdini are called primitives. Okay, you might be knowing it by polygons. See, but it's the same in Houdini. Okay, primitives itself has 228 primitives and polygon is also 288 polygons. Okay, if you can't see, let me just share the screen. Let me just share the complete screen. All right, you can now see my complete screen. Okay, so as I press I, you can see that we, oh, sorry, not this, we have 288 primitives and we have 288 polygons. Okay, so basically you know that a polygon is a surface, but in Houdini we say it as a primitive. Okay, basically any surface that you see is a primitive. For example, if I press I on this ad, you won't be seeing any primitives or polygons. Okay, basically we only have points here, right? So anything that is a surface, it can be a line, it can be a box, it can be any shape, it is a primitive in Houdini. Okay, and polygon is the same thing, that's not like no difference. Okay, so we go ahead with attributes. I have already created something for attributes, so for example, I always give a example of food, okay, because it is easier to understand how attributes are. So, what exactly are attributes? If I talk in a generic way, what exactly the word means, like what exactly is an attribute? So, basically, attributes are nothing but a description of something. Okay, for example, let me take myself as an example that I am Arjun. Okay, my name is Arjun. I might have a age. I might what? I have a age. I have a profession. I have a phone. I have a place to live. And this is my address. This is my phone number. This is my height. This is like black T-shirt that I'm wearing. I have a specs. I have a specs number. All of this description that makes me me. Okay, like everything that is describing me is my attribute. Okay, so basically a description of something which makes that particular person or makes that particular thing. So basically in Houdini, it's a similar stuff. Okay, anything that has a description. Okay, for example, if I talk about speed, for example, a car is going at a speed of 20 kilometers per hour. Okay, so there is a car. The car has a color. It is red in color. Okay, it is going in a speed of 20 kilometers per hour, and it might have a size. It would be in meters or height or whatever it is, right? It is a 4-seater, it is a 7-seater. So all of this description that makes that car, that describes the car, okay, the definition of what the car is called attributes. Okay, in general terms, but in Houdini also it's the same. For example, I talked about an example of the car going at a speed of 20 kilometers per hour. Okay, so basically the 20 kilometers per hour is the speed of the car, and that is denoted as velocity in Houdini. Okay, basically velocity means the speed and direction at which the car is going, or anything, as say. Okay, not only the car but anything which has a direction or speed is called velocity in Houdini. Okay, so that is a description of that car. So that is the attribute of that car. Okay, so basically uh, in Houdini, it wouldn't be like that. I have a specs number, I am wearing a black t-shirt, or my height is 180 centimeters or whatever, right? We have certain attributes that are, defined in Houdini by default, and there can be attributes which I can create for my own values. Okay, so it's not that we have to only use attributes that are created in Houdini and given us to by like Houdini only. Okay, right? So attributes are something that has a very default meaning in Houdini, which is like descriptive of whatever simulation you're doing or model you are taking or texture you are having, right? So the definition of what exactly defines that product or that surface, that model or that simulation are called attributes. Okay, so we will discuss a little bit about attributes, like what exactly it means and how we can read it in the geometry spreadsheet and what are the default attributes. And yesterday I took a class in Hindi and I told them that I would be sharing this page where we have a list of attributes that are predefined in Houdini. Okay, for example, if I type V, it knows that I want velocity. Okay, so I would be sharing that page today because I didn't yesterday. I didn't want to confuse other people that might have not known what went into the class. So I would be sharing it today, and let's go ahead with it, and I will explain to you like what are the different types of attributes, and then we are going to talk about data types. Okay, because having attribute and understanding attributes is necessary, but which data type is that attribute of, right? That is equally important, right? So I will talk about data types also, but let's just ask you guys if you have any doubts regarding this, and then we can take it further. No doubts. Okay. So moving ahead, right, we are going to talk about attributes a little bit. So coming back to the point example, we did have a point here, right? And let's not confuse you guys. I'll just take a single point, right? For example, this. Where did it go? Yes. This is a point that we had in the middle of the grid, right, which stands at 0 0 0. Now how would I know that this is at 0 0 0? Because I can read the data from three places. Okay, first I can read it in the node itself, that the point 0 meaning this point 0. Okay, let's just understand that in Houdini, data always starts with 0. Okay, it does not start with 1. 0 is counted as 1. Okay, but it is denoted by 0. So 0 itself is also a value. Okay, so point 0. We have a point, okay, we have 1 point, so it is point 0, and it says we have 0 0 0, which means this is the axis. Okay, when I talk about axis, it obviously means three directions, x, y, and z. So this is x, y, and z. Okay, now again, I don't know if this is x, y, or z, and I'm still confused as to why is this 0 0 0 and why is it x, y, z. Okay, no problem. So the other place that we can read the data is here in the geometry spreadsheet. Okay, the similar kind of data, we have a point 0 here, and we have a x, y, and z. Okay, and which is 0 0 0. Now x, y, z is okay, but what exactly is this p, capital P? What does it stand for? All right, it stands for position. Okay, if I press I and if I see it here, it says one point attribute, which is a capital P. Now 3FLT pause, what is this? We'll understand it later. But for now, you should understand this capital P stands for position. Okay, position of what? Position of exactly this point, right? So let me just draw it if possible here. Okay, P stands for position. Okay, and we have a point here. This is my point. P stands for position. Similarly, we do have a lot of other attributes. If I just draw it here, small v stands for velocity. Okay, pardon my handwriting because I am doing it from a mouse. And then we have a capital N, which stands for normals. We did see P, so I'll just write P again, which stands for position. Okay, and we do have a lot of other expressions and other attributes. Okay, for example, T stands for time. Okay, and then this is not exactly an attribute, but this is used for an expression. Okay, and what else do we have? We have a velocity, we have a normal, we have position, we have CD, capital C, small d for color. Okay, and a lot of stuff. Okay, we have U, we have V, right, and we have W for angular velocity. These are all advanced stuff, so let's not discuss all this. But yeah, we do have a lot of default attributes as said. So whenever in Houdini, if I type C and D, Houdini will give me a color. Whenever I type small v, it will give me a velocity. Whenever I type n, it will give me a normal. So how exactly to remember all of this? I will obviously send you the page that I was talking about, that you can easily have access to like what are the defaults attribute that I used, and obviously I can use more attributes other than this. Okay, the default one. So let's add something here. For example, this is a point. I know that this is a P of X, P of Y, P of Z, meaning position of X, position of Y, and position of Z, which is in 0 0 0. Okay, but if I move X, for example, like this, it has gone to 1 meter, right? I typed 1 year, but it has gone to 1 year because as discussed, this is a 1 meter range. Okay, this is a 1 meter, so this is in 1, and now you can see the data is updated in X. We have a point in 1, right? Previously it was 0. If I do it again, it was in 0, but as soon as I updated it, it is in 1, right? So let's add more of these datas, and then we'll understand how to read the data types. Okay, now let me add a node which is called facet, and through this I can add normals. Okay, now I do not have a normal, so let's just not work on a point, we'll work on a primitive. And as soon as I connected the spear, now you can see we have a lot of points and a lot of data here, and this might be overwhelming and scary, but now we know that this basically means that you have the point numbers. We have 265 points but with plus 0, so I can see that I have 265 plus 0 meaning 266 points, right? And I have a position X, position y and position z of each of these points that is in 3D space. Okay, this is the position of each and every point that is in 3D space. And now there is nothing to be scared of because I know these are the point numbers and these are the positions. Okay, now let me add something else which is called normals. Okay, we can add normals through this facet, not basically add, but we can compute normals. In Houdini, normals are automatically calculated at every stage, but if you want the attribute n for the normals, you'll have to compute it. Okay, so if you guys don't know what exactly normals mean, normal means whatever side your surface is facing on. Okay, for example, here I have pressed this small little icon of a pin which says display normal. So as soon as I press it, you can see we have an arrow going outwards. Okay, so basically what this means is that basically this is a point normal right now. So wherever my point is facing, the direction of the point facing is the normals. Okay, so we do have a point normal, we do have a surface normal, we do have a primitive normal. Primitive and surface are basically both the same thing. Okay, and we do have a vertices normal. So vertices is not something that we use in Houdini. Primitives somewhat to some extent, but most of the time we would be working with points. So we have a point normals here. Okay, so basically normals tell us that what direction the point is facing. Okay, you can see that each and every point that is facing in a different direction is shown by this line which is called normals. Okay, so as soon as I've computed the normals, you can see I have a nx, ny and nz. So basically the same thing again, whenever we talk about direction, we will always have three directions, x, y and z, right? So similarly normals does also have three axes, x, y, z, and each and every point is facing in different direction. So we have a normal x, normal y and normal z. Okay, then I can add a velocity. Okay, so I have a velocity here. I will compute the velocity. So now you can see we have a velocity attribute. Similarly, as I mentioned, velocity, which means speed and direction of anything that is moving. Okay, but currently this particular sphere is not moving. It is stable in one position, right? So we do not have any information for the velocity. You can see everything is zero, right? But let me add a transform here. Okay, and I will add some expressions here. This is a sine cos function which will just make the sphere go round and round like this. Okay, and now if I check my velocity, you can see my velocity is being updated, right, in x and z direction because I did the transformation in x and z only. Okay, so how does Houdini exactly know that the velocity was used and it has a speed and direction? Basically anything that is moving, okay, either in simulation or by a force or by transformation, anything that will move will have a velocity vector. Okay, velocity attribute basically. So we just need to compute it similarly like how we actually have a normal, but we have to compute for this n attribute. Similarly, I can take a trail node and I can put the result type to compute velocity here, and you can see I do have a velocity attribute here, small v x, small v y, small v z, basically in x y z direction, right? Like which direction the velocity is moving, the sphere is moving, correct? And then after this, see, I can also visualize the velocity here, right, from the map like or icon, pin like icon here just below the normals one. Okay, this is my attribute vector, velocity vector basically. Okay, now let's add another attribute which is called color. All right, color. Okay, you can see we have a new attribute which is called CDR, CDG, and CDB. CD stands for color diffuse, as I did mention here that we have a color here, color diffuse. Wow, very good. F. Let me write it again. Color diffuse. Okay. So it is denoted by C, capital C, and small d. And basically you can see RGB, because we know that colors are made with RGB. Okay, so here similarly it is of three directions, right? R, G, and B, or you can also know it as X, Y, or Z. So I have put a one value in R, so my sphere is R, and the data is updated here in R as 1. Okay, but if I did green, you can see CDG is 1 now, and similarly for blue, CDB is blue, right? So these are some predefined attributes that Houdini knows, that if you type CD you want a color, if you type N you want a normal. Okay, but there are attributes that we can also create. For example, if I create an attribute create here, and I will delete, or let's just bypass this, and you can see there's a new attribute called attribute 1. So I can just change the name, for example VfxBoi. Okay, let's just add the channel's name for promotion. And I put a value of 1 year, right? So Houdini does not know that VfxBoi exists, right? It does not have to do anything with VfxBoi, and it does not care, right? But we can have a value with this attribute VfxBoi. VfxBoi is the name of the attribute, and the one below is the value of that attribute. So for example, if I have two cars, okay, and one car which is called VfxBoi, other is just the car. Okay, so what I can say is that follow VfxBoi's car. So VfxBoi has a value of 1, so the car is moving at a speed of 1, right? So both the cars will follow at the speed of 1. Hope it does not make you confused, and it makes sense. So I can use this attribute anywhere that I like, because it does have a value of 1. If I do it like 10, it has a value of 10. Okay, basically in Houdini attributes are everything and datas are everything. Anything that you work on or will work on, or have a simulation or transformation or animation, whatever it is, it will always have an attribute, and it will always have a data with it. Okay, for example, we have this position, it has its data. We have an attribute named as VfxBoi, it has a data. This P is also an attribute, by the way. Okay, this is the position attribute. And if I just start this again, we have a list of data, and obviously as you start working and in simulations, it is gonna be a handful of attributes here, and you might get confused, but we now know that how it is read. Basically anything, anywhere, or any such thing related to direction will always have a three direction or three attributes, right? X, Y, and Z. Or if it's a single attribute, you will always have a single attribute. For example, like this VfxBoi, it has a single data, right? Now moving ahead, we will learn about data types, but before that let me show you if I delete this attributes. Okay, if I do a attribute delete, and as discussed that everything we are doing is in point. Okay, currently we will we are working in points, and we are not working on primitives, right? So in point attributes, if I delete color, I don't have a color, and if I delete normals, I don't have a normal now. And then if I delete velocity, I don't have velocity, and if I delete VfxBoi, I don't have a VfxBoi. Okay, the place to look for is here. Always keep this geometry spreadsheet right in front of your face, because you should know where the data is going, where the data is coming from, and majority of the problems or mistakes arise when your data does not go to the place that it should go. Okay, basically it might be that you are putting a float value in an integer or a string or in a different place, not on points or primitives. We will talk about all of this in detail, but it always is the problem that if you don't put your attributes in a place that it should go, it will not work, right? So I've deleted all the attributes here, but if I delete P, I can also delete p. It won't be deleted. Okay, because if I delete p, it will not exist in the first place. So I cannot delete p. Okay, in Houdini we cannot delete the actual position of a particular thing. Okay, so attribute p will always be there, and with that obviously we'll always have a point number, right? This is the point number of this sphere. I can check what are the point numbers. See, this is not a point number, this is a point number, right? You can see the point numbers and the position of each point, right? So you cannot delete p. I hope it's clear with everyone. Do you understand like what I'm talking about? I'll just wait for 2 minutes for you guys to ask me questions. Cool. If I don't have any doubts, we can move ahead with the data types. Let me just copy some data and data types. Cool. What is this? New stuff. We just learned about attributes and now we are learning a new topic which is called data types, because wherever attributes go, data types will follow. Okay. So we need to understand what attributes we are creating and what are the data types of that attribute. Okay. So let me just take a sphere again, and this time, okay, just create a primitive, a normal primitive. Okay, basically a normal surface. And now I am going to show you different kind of data types that we have in Houdini, which is related to or connected to the attributes that we are going to use. And we do have a lot of data types, but the majority of the data types or the types of data that we majorly use are four. Okay, which is called float, integers, strings, and vectors. Okay, so these are four data types. Obviously there are quaternion and there are matrices like 3 into 3 and 6 into 6 and 9 into 9 full transform, pack transform. That is a different advanced topic, but if you are interested in that, obviously you can learn more about it. But for basics, for beginners, or for majority of the work that you are going to do in Houdini will only consist of this four data types. Okay, float, vector, string, and integers. Okay, so I am going to show you how it is read and what are the differences between these data types. So let me just create a new attribute, create here, and I will name this attribute as float. Okay, and just let me give you a value of 1. So any data that is in decimals, okay, it has a point and it follows with decimals. Basically decimals means there's this single point that you can see after the data after 1.0. So any value that has a decimal number is called a float value. Okay, for example, if I type point whatever value, you can see it is 1.65544. Even if I type 2, it says 2.0. Even if I type 1, it says 1.0. Even if I type 100, it says 100.0, or whatever value I put. Anything, any data that is in decimals is called float value. Okay, and if you recognize the previous data that we have here for position, it is also a float. 0 0.0, 0 0.0, 0 0.0. Okay, let me just transform this to 1. You can say 1.0, 0 0.0, and 0 0.0. So basically position attribute is also a float attribute. Okay, moving on to the next one, let me just create another, and I will name this as integers. Let me just change the type to integer and press 1. Okay, not integers but integer, right? Now you can see that we only have a single number. It does not have any decimals or points or anything as such. Okay, it's just a single value 1. So anything that is a whole number, like which does not have any which does not have any float values and decimal values, so it is called integer. For example, if I do 1.4, it's still 1. But as soon as I type 1.5, it is round figure to 2, because basic math logic that anything above or anything 1.5 or above will be rounded up to the next number, the greater number 1.5. So it is 2. But if I do 1.4, which is lesser than 1.5, so it takes a lower number and it is 1. Okay, even if I type 1 2 3 point whatever value, you can see it has rounded up to 1255. Okay, it will never have a decimal value. Okay, so anything that is a whole number is called a integer. Okay, now move on to next, which is called string. I write string here, and a string data. String data is nothing but a character data. Okay, a name. It is not a value, it is just a name. Okay, for example, if someone has a name of 1, it will be called 1. This is not a value. If I do 1 plus 1, this will not work. Okay, because this does not act as a value, it just acts as a name. Okay, so this is just a name, 1. So I can type anything here, for example, VfxBoi 1 exclamation or at the rate or hashtag or whatever it is. See, you can see the value itself is a name. Okay, it is not a value. I cannot do 1 plus 1 here and say why it is not working, because it won't. It is just a name, not a value. Okay, but in other cases these are values, 100.557. so if I do 100 plus 100, it will be 200. Okay, but with string it won't work with this 1 plus 1. Okay, because this is just a name. Cool. Not VfxBoi, VfxBoi. Okay. Okay, and the last type of data is a vector data. Okay, let me just type vector here and vector. Usha, we have already discussed this in Hindi yesterday. So if you would like to watch this in Hindi, please do visit the channel and you can check yesterday's live. We are doing a alternate class in Hindi and English, so you can just check it. Okay. So vector data basically has three axes. You can see vector x, vector y, vector z. Similarly to any attribute that has three directions, as I mentioned, will always have a like x, y, z direction. So vector is the direction value. It has a three axis value, okay, for x, for y, and for z. And sometimes while working, you might be asked for a vector data, or you might be asked for a three float data. Okay, so don't be confused, because those two are the same. Vector means three type data, and it is called three float because of the similarity between the data type. You can see, for example, p has a three values like x, y, and z. So we know it is a vector value or a vector attribute because it has three directions, and it is in float, right? 1.0, 0.0, 0.0. And similarly, vector data is also xyz and has a float value 1.0, 0.0, 0.0, right? So anytime that you are working with vectors or directions or three float data, you will have a vector value which has three direction value. Okay, so you can individually work on x, y, z, but it will always give you a three axis data, right? Is it clear for you guys, like what exactly does it mean, like all the datas and data types? Do you guys have any doubts regarding any of the topics that we've discussed today, or regarding the previous topics, or anything in general as such, that what does what mean, something like that? So if you're interested in RBD, you might be knowing that I do have a upcoming RBD class, okay, which we are gonna start soon, because I have already wrapped it up, but I have to make a structure, right? Like how I'm gonna teach it. So I'm still working on it, and it will be soon out. So you can just pre-enroll in it, and I can give you the access as soon as it's live. But I do have a session. Of RBD. If you are interested, you might have watched the trailer on my channel or before this stream started. So If you're interested, please do enroll. And if you guys have interest in Houdini, like much more than this that I'm teaching, so and you want to dive deeper, so we do have a advanced or basics to advanced course in Houdini, where it will be a 3 to 4 months classes, and obviously it is a paid class. So you can just enroll it, and we can start from the very scratch and take you with all the vex and wops, all the simulation types, and how to create a showreel. And you will obviously have a showreel ready by the end of the sessions. So because we work with examples that are used in the industry, and not something like random which is not of use, or you are just confused what to do, how to go. But I do have a structure, and we follow that structure and learn a lot from scratch, okay, rather than just creating something and not understanding how it is working. I do tell you about what are the basics and what are the definition of a parameter and how the value is working, where is this coming from, and things like that. Okay, so basically whatever you see in this live workshop, this free live workshop, is just a scratch or just a basic stuff of what I teach in the damn Houdini class. So if you're interested, please do text me after the call, after this session basically, and then I can join you in the group. Right, so if you guys have any doubts or do not have any doubts, we can end this session here, and we will continue this on Monday, because Sundays we do not have any classes, and tomorrow is Saturday, so I will be having this session in Hindi, not this session but the new session which is on Vex and VOP. So the next session in English would also be in Vex and VOP, but if you do know Hindi and want to join and want to understand it better or understand it twice, so you can join the Hindi session tomorrow, which in which I will cover the Vex and Warp topics and how to understand what to read, how to read, and how to make it less scarier. Okay. So thank you so much for joining, and we can wrap this session up. Okay, I was expecting a lot of people today in English, but I assume I do not have an English audience. I do have a Hindi audience, so it's fine. But if you guys do have any doubts in English, Hindi, or no, I don't know any other language other than this. Uh, but yeah, if you have any doubts in Houdini or in Vex or Wops or something like that, you can always chat with me on WhatsApp. I will just reply you quickly, and that is it. And Dipesh, yes, I do have your flip simulation coming soon. I have recorded the class, and it will be out in the next week or maybe Sunday or something like that. So the flip simulation merge with Ocean Spectrum is coming soon. Okay. So thank you so much for joining, and please do come back for the next session. And if you are new to the channel, please do subscribe, like, and share, or whatever you can do with this. And please do keep learning. Thank you so much. Bye bye. Good night.